Yeah, so for today we'll start with this physics tutorial sheet 2. So this physics tutorial sheet 2, we started from this question 1, which says that the position of the vector is given by xt is equal to 3.02 t squared plus 0.5 t to the power 4 meters. So you have been given that this is the displacement. In short, this is a displacement that you have been given, which is x, which is d here. Xt is equal to 3.0 t squared plus 0.54 meters, like that. So here the first question is asking us to say calculate the average velocity between 1 second and 2 seconds. So they're saying between 1 second and 2 seconds. So first of all, you write the formula for average velocity. So the formula for average velocity, it's a change in displacement over the change in in time. So if you look at this question, what time you have been given? So we have this time, which is 1 second and 3 seconds. So meaning that our initial time is 10 seconds, then our final time is 3.0 second, like that. So meaning that we need to find the displacement of this time, and also need to find the displacement of this time. How do you do that one? That's when you say you say x. Now this one, we will place it everywhere where there's t in this equation. So meaning that will be 0.5 to the power 4, like that. Now let's replace with 1. So let's replace with 1. Such that you have 3 here, because this is 1 times 1, it will just give you 3, plus this times 1, which is to the power 4 here, right? When you say 1 times 1 times 1 to give you that, it will be 0.5. Your answer will be 3.5 after adding meters. So this is your initial initial displacement. So how are we going to find the final displacement? Now we will replace with with 3, which is wherever there's t, you replace with 3. So remember that you have 2 here squared. So this is 9 times that, it will give you 27, plus this is 3 times 3 times 3, that is 81 times this, it will give us 40.5. when you add, it will give you 67.5 meters. So this is the final displacement. So now after that, now we can calculate the average displacement, which is says the change in displacement over the change in time. So what's the final? The final is 67.5 minus what's the initial? It is 3.5 over what? The time, the final time is 3 minus 1, such that there you give 64 over 2. Then your answer would be 32 meters per second. So this is your average velocity. So this is how you calculate the average velocity, just like that. Then let's go on question 2. Let's go on question 2. So on question 2, what are they asking? They're saying calculate the average acceleration at t is equal to 1 and 3.0. So how are you supposed to do that one? So for us to find the average acceleration, remember the average acceleration, what's the formula? The change in what? Velocity over the change in time, like that, right? So what are you supposed to do in this situation? Remember that the one that you've been given, let's say displacement, meaning that you have to differentiate this equation to velocity. So how are you going to do that one? That's what you say. So differentiate this equation to velocity so that we can have the what? The velocity. So meaning it will be dx over dt, right? Meaning this one times this one, okay, dx over dt is just the same as equal to what? To velocity. So it means this one times this one to give us what? 6t2 minus 1 plus 0. Oh, this one times that one, it will give us what? It will give us the it will give us what? It will give us the, which is 2, like that, right? Which is 2, then 4 minus 1, such that your velocity will be 6t here plus excuse me, plus this is t2 then to the power 3. So this is your velocity, the one that we have found. That's a velocity. That's a velocity. So from there now we find the velocity at what? At initial, and the velocity at what? Final. So remember that we have time initial, which is 1 second, then time final, which is 3.0 second, like that. So let's replace wherever there's what? T there. So meaning that t final we replace with this t initial or t final, like that, right? So meaning that wherever there's t, we replace with what? With 3. So it will be 3 there plus 2, 3 there, right? Cube, like that. This is what? It will give us 18 plus this is 27 times that is 54. When you add these ones, it will give you 72 meters per second, like that. So this is your t, that's your velocity final. Now let's calculate the velocity what? Initial. So you replace with 1 now, which is t1 here, plus wherever there's t, you replace with 1, then it will be 6 here plus 2. Then your answer will come up to what? To 8 meters per second. So that's your initial. Now the average velocity will be a, like that, v final minus v initial, then t final minus t initial. Then your velocity is supposed to be 72 minus 8 over, what's your time final? Your time final is 3 minus 1 is equal to then here to be 64 again over 2. When you say 3 minus 1, it will be 2. Then what will your answer to be? 32 meters per second what? Squared. So this is your average acceleration. So this is how you calculate the average acceleration on this point. Let's go on question 3. So question 3, what is really asking us? So the question 3 I say calculate the instantaneous velocity. As I said that for us to find the velocity, meaning we have to differentiate the what? The displacement. So it will be dx over dt is equal to this time that is 6t then 2 minus 1 plus this time that is what? 2 there then 4 minus 1, such that this one, the differentiated equation, it becomes what? The velocity. So it will be 6t to the power 1 plus there 2 to the power 3, like that. So the instantaneous velocity, meaning we just replace wherever there's t there, since here in the question they have said what? They have said at t is equal to what? 2 seconds, meaning that let's replace wherever there's t, the 6 here, 2 there, plus 2 then 2 cubed, like that. What's the answer there? To give us 12 plus this is 8 plus that is 16, meaning your answer to be 28 meters per second, like that. So this is how you calculate the what? This question which is here. Now let's go on that question. Calculate the instantaneous what? Acceleration. So how do we calculate the instantaneous acceleration? So here remember that after I've differentiated the displacement, I've come to what? To the velocity, meaning that if I differentiate this equation for the velocity, I'll come to what? To acceleration. So if I say dv over dx, then here we have 1 times that is 6, then 1 minus 1 plus here, right? This time that is 6 t then 3 minus 1, meaning that after differentiating this one, it becomes what? Acceleration. So to be 6 here then t to the power 0 plus to be 6 here then t to the power 2, such that a will be 6, any number to the power 0, it's 1. So here it's 1, meaning it's 1 plus 6t here. Then a is equal to 6 plus 6t squared. Then your instantaneous acceleration will be, here they have said at t is equal to what? To 2 seconds, meaning it's supposed to be a is equal to 6 plus 6, then you replace with 2, it will be 6 there plus, or 6 squared plus 2 times 2, that's 4 times that, it is what? 24. So you'll find that your answer will come to be 30 meters per second what? Per second squared. So this is how you solve this question, like that. Let's go on question 2 now. Remember the one that we're doing, we're just doing question what? We're just doing question 1. Now let's go on question 2. So question 2 reads, the same on dry concrete, a car can deaccelerate at a rate of 7 meters per second squared, where at wet concrete it can decelerate at what? Only what? 5.0 meters per second squared. The first question says find the distance necessary to stop a car moving at what? Moving at 30 meters per second, right? About 110 kilometers per hour, right? The first question, it's A. What did they say? They said that on dry what? On dry concrete. On dry concrete, right? So how do we find that one? So this one will just use the simple formula, which is supposed to say what? V final squared is equal to V initial squared plus 2ax. So this is the V final, which is the velocity final, then the velocity initial, then this is the acceleration, what? Acceleration, this is the displacement. So on the dry concrete, they are saying that it deaccelerate at what rate? That is 7, right? So if you see this word deaccelerate, meaning that your acceleration becomes what? It's negative. In short, your acceleration will be what? Negative. So here they are saying that it was moving at what speed? It was moving at the velocity of what? So if it was moving, meaning that it had no final velocity, the final velocity will be 0, but the initial speed that at which it was moving at 30 meters per second, like that. So what's your final velocity? The final velocity in this situation is 0, like that, equal to initial velocity is 30 squared plus what's your deacceleration? That's negative 7, then x. Here what are we finding? We're finding this x. It means that we're finding the what? The displacement. So here to be 0, like that. What's here to see? 900. Then there to be, it will be here to be negative 14 x, such that when I get this negative 14 and I put it, I make this the subject of formula to be what? Positive x is equal to 900 divided by 14 divided by 14. Then you come to realize that you have the answer, which is what? 16. That is 900 divided by 14. So your answer to be 64.3. So that's your displacement. They're saying find the distance necessary to stop the car. So meaning that this was the distance that was necessary to stop the car on the what? Dry concrete. This is just on the dry what? Dry concrete. So I can say this is the displacement for the braking. So I can say displacement for the what? For the braking, right? Now let's also do question B. So question B, what is it saying exact? Question B, what is it saying exactly? It's saying the same thing. Now here, remember that here we're calculating on the dry, here now we're calculating on the what? On the wet concrete. So we just use the same thing. What was the acceleration? Sorry, what was the acceleration? The acceleration was, the deacceleration was what? Negative 5 meters per what? Per second squared. Now let's write our formula, the one that we're using, which is final is equal to V initial, like that, plus 2ax. So what is the final velocity? The final velocity to be 0, like that. Then the initial velocity, the one that we had, is 30 squared plus what's the acceleration, that's negative 5, then x, then here to be 0 is equal to, this is what we call 900, then minus 10x, then this one when it goes to the other side, that is what, 10x is equal to 900 over 10 over 10, such that this one and this one, they'll divide, then your displacement will be 90 meters. So on the wet concrete, it means that the braking system it need about 90 meters, right, for braking. How about this one? The displacement was what, 64.3 for the braking. So this is your what, this was your displacement for the braking, all of them on the dry and what, concrete. So let's do on the question, remember this was question 2.1a. so let's do on question A2 now, which is this one. So question 2a, it says repeat both calculation and find the displacement from the point where the driver sees a traffic light, taking into account his reaction time is this. So I want you to look at the reaction time. So the reaction time there, we had what, 0.500 meters, 0.500 seconds, sorry, that's a reaction time. Then it was moving at what, 30 meters. So for us to calculate the displacement for the weight from the time they started braking and the point of the reaction, we need first to calculate the displacement for the reaction time. So how do we calculate the displacement for the reaction time? So for the reaction time, we say it's just the same thing there, plus vt, like that, right? So here the initial displacement is 0, like that, plus what was the time, or what's the velocity, like that, that is 30, then the time was 0.5, such that here to be 0 plus 15, then to be 15 meters. So this is the displacement for the what, reaction. Now if you remember properly, we said that the question is saying that you have to calculate the total displacement on the concrete from the what, from the breaking up to the reaction point. So meaning that what I supposed to calculate here, we're calculating the total time on the dry weight, in short, on the dry concrete. So how are you going to do that one? Meaning you're supposed to say x total is equal to x braking plus x reaction. So meaning that this x braking, we had to what we had there on the question, on question 1, we had about 64.3 plus for the reaction, which is what, 5 meters, then 15 meters, then your answer will give you what, that is it, 79.3 meters, like that. That's when it's on the dry concrete. Now how about on the wet concrete? So on the wet concrete, it's supposed to be total here, right, is equal to what, the same thing, that is the braking plus the reaction. So meaning that you be for the braking, what are you having for the braking? On the weight you had 90, we had 90, right? Plus for the reaction, which is 15, then here it's supposed to be what? 105 meters. So this is how you calculate question A, question A2. So that's how you calculate that question on that one. Let's go on question 2B. So on question 2B, this is question 2B. Which is this one here. They're saying that the cheetah waits in hiding behind a bush. The cheetah spots a gazelle running past at 10 meters per second. At the instant the gazelle passes the cheetah, and the cheetah accelerates from rest at 4 meters per second to catch the gazelle. So what are you supposed to do? They're saying how long does it take the cheetah to catch the gazelle? What is the displacement of the gazelle and the cheetah? Then the other one says sketch the velocity time graph and the distance time graph for the situation. So in this case, what are you supposed to do in this way? So here are the issues that you need to take note of. So here, first of all, let's get the data. So we have the cheetah that was waiting in the gazelle, right? So meaning the initial speed here it is 0 because it was waiting for the gazelle and it was at 0. And again it say it started from from the rest, so meaning that the initial speed is 0. How about the acceleration? The acceleration, it started from the acceleration, which is that. How about the gazelle? The gazelle here is that it was moving at 10 meters per second. If it was moving at 10 meters per second, meaning that it was the velocity was constant, so meaning it's supposed to be 0 like that. So let's try to solve this one. So here we just say x is equal to VIT plus 1 over 2, then AT like that, right? Squared. Then x is equal to, what's the velocity? The initial velocity is 0, then t plus 1 over 2. What's the acceleration? It was 4, t squared. Then x is equal to 0 here, plus, what's the answer here? That it will be 2t squared. Then your answer will be x is equal to 2t squared like that. So this is your equation 1 for the cheetah. Let's find the equation 2 for the gazelle. You can just go there with this formula, which is VTI like that. X is equal to initial velocity 0 plus, what's the initial displacement 0. What's the initial velocity? That's 10 like that. Then x is equal to 10t, just like that. So this is your equation 2. So we have this equation for the cheetah and also the equation for the gazelle. So in this situation, what do? You just equate these two so that you calculate the time the cheetah catch the what? The gazelle. So we're supposed to say 2t is equal to 10t, like that. We have just equated that. Now over 2t here, over again what? 2t here. This 2t times that divided by that, it will give you what? T is equal to, this is 1 and this one, it will give you what? 5 seconds. So it means that the cheetah catch the gazelle in how many seconds? In 5 seconds. So that's how you answer question 1. Question 1b. Now let's go on question 2b. So after finding that, let's go on question what? 2. So they're saying what is the displacement of the gazelle and the cheetah. So remember that the displacement, the equation displacement of the gazelle and the cheetah, we had something like this, and the gazelle we had the 10t, like that. So meaning that here the time that it caught, it was 5 seconds, then 10 here again, that is 5, like that, right? This is 5 times 5, that is 25 times that is 50. Then here again that's what? 50 meters. So meaning these guys, they took what was the time? 10 meters or 50 meters, right? So this is how you answer that question. So how about the question 3? They're saying that sketch a velocity time graph and the distance time graph. So let's start with the velocity time graph. So the velocity time graph, remember the velocity time graph, how does it go? Meaning the y-axis is the what? It's the velocity. Then this side is what? The time. Now I want you to look at this. The cheetah started from the rest. If the cheetah started from the rest, meaning it's supposed to start from this side, and it was increasing and it was increasing like that. So it started from the 0 here, the velocity, then it was increasing up to there. Then how about the gazelle? The gazelle, it was just moving at a constant what? Velocity. So meaning that it was just moving at a constant velocity. They met at this point, which is 5 seconds. So this is your velocity what? Time graph. How about the display? How about the distance? Is it distance? Yes. Distance time graph. So distance time graph, meaning the x-axis is what? Is distance, right? So here the x-axis is distance, then here it's what? Time. So what we're supposed to do here, remember that all of them, they traveled at what was the distance? 50, right? So 50, so it's supposed to say just 50 like this, 50 meters like that, right? Then even with the time, if you want, you can put the time down here, which is 5 seconds, like that. That's all. So that's how you answer question B. Hope it's clear on question B. Now let's go also and answer question C now. So on question C, they're saying, let's to see. On question C, they're saying you're driving at a constant speed of, so it's you here, you're driving at a constant speed of 45 meters per second when you pass a police officer on the motorcycle hidden behind the billboard. 1 second after your 1 second after your car passes the billboard, the police officer set out from the billboard to catch you accelerating at a constant what? Rate of 3 meters per second. So here it's you who are here, and police, right? So this police officer were hiding at certain point. For example, you're moving at the speed of 45 or 45 meters per second, right? You are moving, then the police officer, they're somewhere here, right? They're somewhere here. Then after a 1 second, after 1 second, you've passed this police officer. After just a 1 second, then they started what? Chasing you. So after just a 1 second, they started chasing you, meaning that this means that you have left them with some amount of distance, because they started chasing you after what? 1 second, meaning that there's a certain distance that you have left these police officers. So that certain distance that you have left these police officers in what? In 1 second, we call that as the initial displacement. So let's calculate the initial displacement that was here. How are you going to calculate the initial displacement that is here in 1 second? That's where you can say what? Initial velocity is equal to vt, like that. What was the displacement that this guy was traveling, which is 45 times what? 1 second, such that it will be 40 meters, meaning that you left this police officer in how many seconds? In 40 meters. You left them 40 meters away from you. So if you left this police officer 40 meters away from you, meaning that that's your initial displacement. Now let's calculate the displacement, the whole displacement that you moved. You will find that you have displacement is equal to initial displacement plus vit. Then your answer will be, what's your initial velocity? That's 45 plus, initial displacement, that's 45, then plus the initial speed that you are moving, that's 45 times t. So meaning that your equation will be 45 here plus 45 t, like that. So this is your equation 1. Then equation 2 for the police officer. The police officer started from the rest. They started at a constant rate of what? That means 3.0 seconds. So for the police officer, you'll be acceleration is 3, like this, right? Meters per second, like that. Meaning that, I want you to look at this, meaning that the displacement at which the police officer moved what's the initial? It's 0 here, the initial speed, then time plus 1/2, then to be 3 here, which is t squared. Then your x, your displacement will be, when you divide the height, that is 1.5 1.5, after you divide it with 3 there, to 1.5 what? T squared. So meaning that your another equation is 1.5 t squared, like that. So after you have the equation for you and the equation for the police, let's equate them together. So you have 1.5 t squared, then 45 plus, that is 45 t, then 1.5 t here squared. When this one goes the other side, that's negative 45. When this one goes the other side, it's supposed to be negative 45 is equal to what? To 0. So this is your quadratic what? Equation. So this quadratic equation, I'll ask you to go and solve this quadratic equation. So you can solve this quadratic equation by using this formula. By using this formula. So that's how you can solve this quadratic equation. So I can say that let's go on the question 3. So question 3, when look at the question 3 is asking question 3 is saying that a stone is dropped by a person from the top of the building, which is 200 meters tall. At the same time, another stone is thrown upwards with a velocity of 50 meters by a person standing at the foot of the building. Find the time after which the two stones met. So when we have this type of the building which is here, and they throw a stone, it goes like this, come down, right? So they're saying this building, it was 2 meters high, then another stone was thrown up. So what are they asking? They're asking at which these two stones met. They're asking at the time at which these two stones met. This stone was thrown by 50 meters per second. So they're asking you to calculate the time at which these two stones met. So what are you supposed to do in this situation? Let's first calculate the equation for this, for the stone that was thrown from the top of the building. In short, this is the top, this is the down. So let's calculate the equation that was thrown in the top of the building. So how do we calculate that one? I want you to look at this. So this stone was thrown from here. This is the point where this stone was thrown. If this is the point where this stone was thrown, meaning that that's your initial displacement. So what's your initial displacement in this situation? Your initial displacement in this situation will be what? Will be 200. That's your initial displacement. So meaning that the formula that you need to use is just this formula. Final here is equal to initial displacement plus VIT minus 1/2 AT squared. So if you are dealing with the motion in the y-axis, the acceleration here changes to be what? The negative. So here it's supposed to be negative all the time when it has changed. So what will be the final displacement? We don't know the final displacement from this point up to here. So we don't know the final displacement. What are you supposed to do? The final displacement, we say, is equal just to what? To 0. So what's the initial? Your initial displacement is what? 200. Then initial velocity, we don't know since it started from the 0, so it's supposed to be what? 0 like that. Then t minus 1/2. Then 9.81 is due to the gravity. So meaning it is 0 like that is equal to, oh sorry, it's supposed to just be like that. Finally, so it will be 200 minus 4.905 t squared. So that is like that. So this is your equation 1 for the top duty. So how about the one that's from the down? Just use the same equation. So the final displacement is equal to, remember here it's 50 minus 1 over 2, that is 9.81, then t squared, then x final is equal to 50 here, t, then minus 4.905 t squared. So this is the one that from the down. So meaning that the time for the top, the top stone and the time for the down top, the down stone, they're supposed to have the same time, right? So meaning that we will equate this equation and also this equation. Let's equate it. So it will be 50 t then 4.905 t squared equates to that equation, which is 200 minus 4.905 t squared, such that this one and this one, they'll divide, then or they'll subtract, and we have 50t is equal to what? 200 divided by 50 divided by 50. Then here to be t is equal to, when you divide there, to be 4, to be what? 4 seconds. Just like that. So meaning your answer is just what? 4 seconds. Just like that. So that's how you answer this question 3A. So how about question 3B? So question 3B, the saying a stone is thrown vertically upward with a speed of 12 meters. So remember, this stone was thrown vertically upward, meaning it was going in the y-axis upwards from the edge of the cliff, which is 70 meters. Remember, this is your initial displacement. Then how much later does it reach the bottom of the bottom of the cliff? So how are you supposed to answer this type of the question? So we answer this type of the question by using the same formula. They're saying they are looking for the time, right? They're saying how much later does it reach the bottom of the of the cliff. So it means supposed to say what? You have to say displacement final is equal to displacement initial, like that, right, plus v y initial t plus or minus here, because it's in the y, then 80 squared. Remember, this is just 0, like that, and 70 here plus 12t here minus 1 over 2. Then here is supposed to be 8.1 t squared. Then is equal to, that is 70 here plus 12t minus 140.905t squared. When this one goes the other side, that is 4.05t squared minus 12t minus what? I've taken this to the other side, it's supposed to be 70 here is equal to 0. So in this situation, that's a quadratic equation, meaning what I'm supposed to do, we have to use this formula. So now when you calculate everything, you will find that your answer is supposed to be 5.20 seconds after going this this formula. So that's will be what your answer, like that. So let's go on. That's question 1. That's question B1. Now they're saying what is the velocity just before hitting the ground. So now they're looking for the velocity just before hitting the ground. So remember that what is the time that you found? We found the time we found that the time is equal to 5.20 seconds. So that's saying what's the velocity just before hitting the ground. So just use the same formula, just u here, then 80 squared. Then here what is there? That's 12 minus 5.20 here. Then 5.2. Wait. The acceleration, sorry. The acceleration, that's 9.80. Then the other one's supposed to what's the time? 5.20, like that. So which is squared. So here let's calculate what you have in the equation. Let's calculate. So meaning that in that situation now, in that situation you say 12, that is the 5.2, that's 5.2 times 5.2, then times again, that is 9.80, like that. Then from there we say 12. So meaning that when you subtract your answer to give you negative 268.28 meters per second, like that. So this is how you solve your answer, just like that, right? So since I said 12 there, minus, say open like that, that is 9.81 times 5.2 squared, like that. Close. I'm finding something else, just wait a minute. That is 9.81 times open 5.2, like that, minus 12. So your answer is supposed to give you that is 253.262. So the answer is 253 meters per second, just like that. Now here on the last part, which is same question B 3. Now let's go on question B. What? 3. What are they asking? They're asking what's the total distance traveled. So meaning we're being asking now to calculate the total displacement, right? Now I want you to look at this. When you travel like that at the final, then again you travel like this. According to the displacement, that is 0 because it has just come on the same height where it was before. But according to the distance or displacement, according to distance, we only add these two. We add without putting the negative sign or the positive. Just say you add this. Is it okay? So let's calculate the displacement that it moved from here up to where? Up there. So how are you going to do that one? That's easy. Here at the final here, this is the final displacement or the final height. In short, right? At the final height, the final velocity is equal to what? To 0. Remember what it started with? It started with what? According to what it was thrown with. It was thrown with by 12, right? So meaning that you square there to be square there, then 2ax like that. Then here that's 0 like that is equal to 12 there minus 2, 9.8, then x like that. We're calculating the displacement that it moved from here up to where? Up there at the final there. So there, what are you supposed to do in that situation? So in this situation, you're supposed to say this is 0, right? Is equal to 144 minus, that is 2 times 9.81. It will give you 19.62x. When this one goes the other side, as you see, 19.62x is equal to 144, such that that's 19.2, so that is 19.2 xx. Then let's divide that with 144. So 144 divided by 19.62. You find that your displacement is 3 to the power of 7.34. So it's 7.34. It's from here up to here. How about from here up to here? Meaning that your total displacement, you say total displacement, right? You say 7.34 of going up plus 7.34 of coming from here, of coming down. In short, 7.34. How about for the building? For the building it was 70. So meaning that you have to say that one, right, plus 70. Then your answer you give you 84.7 meters. So this is how you answer question 3. That's question 3. What? 3. This question here, they're saying what is the total distance traveled. So this is how you answer that question. Now let's go on question C. Question 3C. So question 3C. Question 3C. They are saying that a basketball is thrown straight upward with the initial speed of that. So the basketball was thrown what? Upwards. Like upwards. Right? With a speed of what? 5 meters per second. So I want you guys to look at this, right? So I said that at the maximum here, the maximum height, this is the maximum height from there up to here. At the maximum height here, the final velocity is 0. Is it okay? So they're saying the maximum height reached by the what? By the ball. So remember that what are we having? We're having these. We're having this, right? This is the only thing that we're having here. Exactly thing that we're having what? We're having the displacement. We're having the displacement, the velocity, sorry. We're having the velocity that was thrown with, and the final velocity, which is what? 0. So how are we going to find the maximum height? We just use the same formula. Final, remember this is C, sorry, C, which is this one. We say final squared is equal to initial velocity squared plus minus y minus, because we're dealing that in the x-axis, 2x, like that. So that, what's your initial velocity? Initial or final velocity at the final height is 0 there, squared is equal to that 5 here squared minus 2981x. So from there, this is 0 is equal to, so we said that 5 times 35, that 5 times 35 will give you 125, like that, minus that one. What's your answer? That is 2 times 9.8, 2 times 9.81, then 19.62x. Then this one goes the other side, that is 19.62x is equal to 125 over 20, that this and that they'll divide. So meaning that 1225 divided by 19.62, it will give you 62.4 meters. So this was your displacement that it took, or the maximum height, that is from here up to where? Up there. So that was your question what? Question 1C. Let's do the other one. So they're still asking us to calculate the what? I think the time taken to reach the what? That height, which is the maximum height, right? So the time taken to reach what? That height. So the time taken to reach that height. So what are you supposed to do in this situation if you're having something that is like that? So meaning here we're calculating the time. So to be V is equal to U, then 80, like that. Initial velocity at the final there is 0, like that. Then what was thrown with? It was thrown with 35 minus 9.81t. And when this one goes outside, that's 9.81t is equal to 35 over 9.81 over 9.81. This and this, it is t is equal to, so let's 35 divided by what? 9.81. You'll find that your answer is 3.57 seconds. So this is how you calculate that one. How about its velocity after it is thrown? Its velocity after it is what? Thrown, which is 30 seconds, right? Just use the same formula, which is u there and 80 here, that is 35 here, then here is 9.81. Now after it is thrown, which is what? 30 meters or 30 seconds, to be 35 here minus, then 30 times that one, 30 times 9.81, so to be minus 294.3. so when you subtract there, you give us what? When you subtract there, it will give us 5 there, right? So it will be negative 259.3 meters per second. So since it's a velocity, so it means that it's just okay to leave it that in negative form. So that's how you answer that type of question, just like that. Okay, let's go on question 4. Let's go on question 4. So on question 4, they're saying a ball is thrown from the top of the building toward right? A ball is thrown from the top of the building toward a top building 50 meters away. The initial velocity of the ball is 20, which is this one, 40 degrees meters above the horizontal. How far or below its level will the ball strike? So meaning that they're asking how far, so meaning how far from this point up there and from this point up where, up there, like how far will the ball strike on top and also down part. So what do you supposed to do in this situation? So in this situation, remember that this ball was moving in the x-axis and also was moving in the what? In the y-axis. So if it was moving in the x-axis and again it was moving in the y-axis, mean that it was moving at a certain what? Certain angle. So this angle, it means that it was moving at a certain angle, right? Meaning that we have the velocity in the x-axis and the velocity in the y-axis. So we use the same thing that we're using there, vectors. Oh, sorry. Since it's the so here it's supposed to be cos because it's in the x-axis. How about y-axis? It's supposed to be sine theta, like that. So meaning that v initial in the x-axis, v initial in the what? In the x-axis is what? That is 20 there, cos 40. This side again you do the same thing, that is 20 sine 40, like that. So what's your answer here when you do that one? So when you do that one, that is what? 20 cos 40. I'll find that here it's 15.3 meters per second. So that is in the y-axis. So it means that it was moving in the x-axis. So how about the other one? That is 20 sine 40. So I'm finding that in the y-axis it moved like 12.86 meters per second, like that. So from here now, I want you guys to look at this, the distance or the range that it took from here up to here they've given us. And remember, this is in the what? X-axis, right? So meaning that we can calculate the time that it took from this point up to this point by using these meters. What are you supposed to do? You're supposed to say the range or the displacement is equal to VIT, like that, right? So what's the displacement here? It is 50 here. Then there it is 15 in the x-axis, remember, t. The range, it is in the x-axis, so it means that we're supposed to use everything in the what? X-axis. 0.3. This and this they'll go, meaning to be t is equal to what? When you divide there, you find that when you divide, you have 50 divided by 15.3. you find that the time that it took is 3 point what? 26, just 7 like that, right? Seconds. So this is the time that it took the ball from this point until it hit here. So how about now to calculate this displacement that it moved, the up and the down one? That's where now, remember that now this is in the y-axis, because we're calculating the whole distance from the up and down, right? This is in the what? Y-axis, meaning that you have to go with the y-axis, but with the same time, because there is just the same time that it moved from here up to there. So what I'm supposed to do there is just to switch that to switch. You say displacement is equal to VT plus 1/2 then 8t squared. So I want you to look at this. The velocity that it moved from this point. Are you seeing this point, right? Here, going down like this. This point was below where it falls, meaning that your velocity here is supposed to be what? Negative. So your velocity will be negative, initial velocity there, meaning it will be negative 12.86 like that. What's the time? It is 3.3 in short is 0 plus 1/2. Then this is supposed to be 9.81 times what? Times the time, which is 3.30. Remember, it's squared there, so it's supposed to be x is equal to, when you multiply there, what are you going to get? So when I multiply there, I'll get something like, that is negative what? That is negative 12.86 times 3.3. Then I'm getting negative 42.438 plus, so 0.5 or just half times 9.81 like that, times the square root of 3.3. Then I'll get something like 50 this side, this is 50, sorry, 50.85. Now let's subtract this to be minus 42.43. So your answer is supposed to get something like 10.3 meters like that. So that is how we solve this type of of the question. This one is not a negative, it's just a 10. So that's how we solve this type of of the question. So let's do B. That's question 4B. So they're saying time of the set. So how do we find the time of the set? So the time of the set is the time of the starting point. It's supposed to be V sine theta like that over G. Then what's the speed at which this was thrown? That's 100. Then sine 60 over 9.81 like that. Now here it will be that is 100, that is 100 sine 60 divided by 9.81 divided by 9.81. So I'll find something like t is equal to 8.82 or 3 short seconds. So this is how you find that one, because if I say 100 sine 60 divided by 9.81 like that, right? So that's how you find that one. Then you also go on time of the flight. So time of the flight is 2v sine theta over g, such that it be 2 here, then 100 sine 60 over 9.81. Then your answer will be what? So here it will be 200, right? It will be 200. It will be 200 then sine 60 divide by 9.81. Then your answer it will be something like 17.66 seconds like that. Then the other one, it is what we call the maximum height. So the maximum height, that will be what? V sine theta squared over 2g. So meaning that, let's see, 100, right? Sine 60 here squared over 2 times 9.81. Then meaning that it will be open 100 sine 60 squared and 60 squared, then divide by that is 9.81 times 2. So it means that your maximum displacement will be 382.3 meters high like that. Is it okay? So that's how you find that one. Then let's do the range now, because the one that we're finding the height. So let's do the range. So the range, the way to be like this. The range, the way to be, the range is equal to v squared sine 2 theta over g. Then it will be 100 squared sine 2 like that over 0.81, such that in this type of the situation now, it will be 100 squared there, right? Sine 120, because sine 120 divided by 9.81. So your range, it will give you 882.8 meters. How about the maximum range? The maximum range, it's v squared over g. So it means to be 100 here squared over 9.81, like that. So there it will be 100 squared divided by 9.81. So your maximum range will be 9.37 meters, just meters, like that. That's all. So how about the other one? The other one says, that is, remember this was question 5, the maximum range possible. Then this is, yeah. Then what's the next question? The next one says what? Question 5 now, which is this one. It says velocity with its initial what? Acceleration. So meaning that we have to calculate the velocity in the x-axis. Again, we need to calculate the velocity in the what? In the y-axis. So here it will be what? 20 cos 40, that is in the x. Again in the y, it will be 20 sine 40. Then meaning that 20 cos 40, here it is 15.32, that is in the x. How about in the y? That is 20 sine 60. It will give us 17.3. Now from there you say, you calculate the magnitude in the x-axis plus in the what? The y-axis. Short, right? So the magnitude of this, that is 15.22, like that, squared, plus the other one, that is 17.32 squared, like that. Meaning that what will be your answer? Your answer will be in this way. So it will be, that is the square root of 15.22 squared plus squared plus 17.2 is 17 squared. And let's find the square root. So here to be square root over 15.2 squared plus 17.32 squared. So here let's find the square root over 533.99Q4. What's the square root of that? What's the square root of that? So your square root of that, the one that I'm finding, is 23.10 meters per second squared. So this is how you find this. So the procedure is more important than anything. This is how you find this one. Then let's solve the last question, which is question 4C. So question 4C, the way it is that they are saying that the projectile is fired horizontally. So if it's fired like horizontally like that, right, meaning it was going in the x-axis. That's why I'm saying horizontally like that. It was moving in the what? X-axis. So meaning that the velocity there, it's just moving in the what? The x-axis, because I said horizontal here with the speed of what? With the speed of, okay, with this, with it was fired horizontal with 30 meters per second, meaning that it was just moving in the what? X-axis. They're saying how long would it take to strike the level ground at the base of the grip. So here, excuse me, here what you are being asked, you are saying how long would it take to strike the bottom of the what? Of the ground. So in this situation, we use the same thing, which is x is equal to vt. How long would it take to strike the bottom of the ground, right? Yeah. So remember that this is vt. Now this is y. It's supposed to be y, right? Here 1/280 squared, like that. That is 80 squared there. What would be there? That would be 0, because this velocity was just thrown in the x-axis. It was not thrown in the y-axis. So like it moved in the horizontal like that. So there to be t there 1/2. What's this? That is 8, 1 like that, t squared. Then it is 80 here is equal to 0 minus that is 4.905 t squared. Then 80 here is equal to negative 4.905 t squared. Let's calculate the time. And then you find that your t is equal to, that is 80 divided by 4.905. 4.905. You find that your t is 16, right? 16, that is 16.3 here, and then you find the square root of that. Then what is the square root of this? It's going to give you what? It will give you the square root of that one. It will give you, that is 16.3. It will give me 4.04 like that seconds. So that's how it's supposed to be. It's giving me, they're saying how far from the foot of the creep would strike, meaning that the displacement from here up to there, what are you supposed to do there? That is 1. Now let's to find 2. The displacement from there up to there, what are you supposed to do? That situation, that's where you come up with this formula. Remember that you are moving in the x-axis now. It will be 30 times 4.04. So meaning that 30 there, then your answer will be 1.1 meters, like that. So meaning that here it is 1.1 meters. So let's go on the other one. So let's go on the other one. What the other one is saying exact? The other one is saying with what velocity will you strike here? So here it is coming with the velocity with the x-axis velocity. It's coming with the it's coming with y-axis velocity. Again, it's also coming with the x-axis velocity. So we already know that the x-axis velocity is 30. So how about y-axis velocity? We need to calculate the y-axis velocity by using this formula. So here it is 0 like that in the y, 9.81. Then what was the time? The time was 4.04. So meaning that the velocity will be 4.04 times 9.81. It will give me, in short, 40 here, right? That's negative 40. Then now we find your magnitude here, x-axis plus the y-axis. Then it will be 30 here squared plus negative 40 squared. Then plus that is 30 squared plus 40 plus that is 40 squared, like that. You'll find that you have 2500. Okay, let's find the square root of that is 2500. You find that your answer come up to be 50 meters per second, just like that. So that's how you answer that question. So how about when it's question 5 now. So question 5. Let's start with a motorcycle traveling 4 meters east. So it was traveling 4 meters east, like that. Then what was that? That is 4 meters second. Then encounter the current traveling what? North. So it counts the traveling what? North. With what speed? That is meters per second, like that. What is the resultant vector? The velocity of the motorist. Which velocity that is? This is the resultant if it's like this, because here it's perpendicular, so meaning that the resultant now will be this. So how do you find that one? I want you to remember the Pythagoras theorem, where it states like r squared is equal to b squared, like that. Then here it's supposed to be r squared, then you just say 7 here squared plus 4 squared. R squared is equal to 49 plus 16. Then let's calculate the square root of this, and this was the square root of, when you add there to give you what? That's 5, then 65 in short. So when you add there to give you 6.0 square root of 60, that's 6.03. Yeah. So that's 6.03, sorry, supposed to be 8.02, like this. So this is your resultant. That's why here you find the resultant, that is meters per what? Per second, like that. So that's how you find the what? The resultant on this one. So let's go on the other one. Now what are they saying? They're saying that if the width of the river is 80 meters wide, then how much later does it take the boat to travel shore to shore? So how do you do that one? Shore to shore, meaning that from this point until that point, right? So remember that it was moving at that, right? This side is 7 meters per second. It will, from here to shore up to here shore, it's 4 meters per second. Now the same, if the width is that, how much later? Meaning that we're looking for the what? Time. So it will be displacement is equal to v I t. What's it there? It's supposed to be what? 8 here is equal to 4, then t over 4 here, over 4 here. That's question 2 in short. Then 4 here to be t is equal to what? 20 seconds, just like that. Then the other one, it will be, now they're saying that what distance down the stream does the boat reach the opposite shore? So meaning that from here up to there. So we are remember that we have the velocity, which is 7 meters per second, right? Now they're saying that with what velocity does with what speed does the boat that? So meaning supposed to say displacement is equal to vt, like that, is equal to 7 here. What was the time that it moved from here up to there? We said is what? 20. So such that you will find your answer to be 140 what? 140 meters, like that. So this is how we solve this type of equation. Now let's go on question 5b. Question 5b. So question 5, they're saying that the car due to east with a speed of 50, right? Raindrops are falling at a constant speed vertically with respect to earth. The traces of the rain on the side window of the car make an angle of 60, right? With the vertical. Find the velocity of the rain with respect to the car. So we are here. I want you guys to understand this. So the car was moving like that, right? So if this car was moving like that, so we have the vertical rains, right? Direct to the earth, like that, right? Remember, this is the car that was moving this side, then it was direct to the what? To the earth. Then from there, this was the what? The window of the car, right? So if this was the window of the car, as the car was moving like this, meaning it was going down at a certain angle of what? That's of what? Of 60. So this I can say rain respect to the earth. Then this down here, this is where the car is moving, so it means supposed to be what? Car respect to the what? To the earth, like that. So how about the other one? The rain, it was dropping to the car, so it's supposed to be what? Rain respect to the car, like that. So this is the rain respect to the earth, car respect to the car, or car respect to the earth, then rain respect to the car, because it was dropping at what? At the car window, so it means it was going like that, right? So what are you supposed to do in this situation? Remember that the car was moving at what speed? That is 50 kilometer per hour, like that. So 50 kilometer per hour. So the first question is say find the velocity of the rain with respect to the what? To the car. So means that rain respect to the what? To the car. So where is rain respect to the car according to what have been given this? Remember SOHCAHTOA, right? So this is hypotenuse. The opposite of this angle here, it is this part. That's the opposite. Then this part is what? The adjacent, right? So this is the opposite, and this is the hypotenuse, opposite, adjacent, like that, right? So if I draw SOHCAHTOA, you find that they're saying that find the velocity of the rain with respect to the what? To the car. So rain respect to the car, this is the part that they are looking for. So how are you going to calculate that one? Remember, what are we finding? We are finding the what? We are finding the, here in this situation, we are finding the hypotenuse. So we have the opposite, meaning that which sign I'm supposed to use? I have to use sine. So to be sine theta is equal to opposite over hypotenuse. So what's the sine? Sine, the angle there, it is 60, is equal to what's the opposite? Car respect to the earth. Then what's hypotenuse? Oh, car respect to the earth, yes. What's hypotenuse? That is rain respect to the car, such that it will be sine 60 this side. Car respect to the earth, we said is 50 over rain respect to the car, like that. When you cross multiply here, it will give you R is equal to this one times that one, it will be 50 this side over sine 60. What would be the answer? If I say 6, what would be the answer? That so the answer would be 50 divided by sine 60. Then I'll find the answer something like 57.7, like that. So this is how you solve this one. Then how about the other one, which is question 2? So question 2, they're saying find the velocity of the rain with respect to the what? To the car. So there's find the velocity of the rain with respect to the earth. The rain respect to the earth is this side. So what are you supposed to do in this situation? In this situation, the thing that you need to do is this. So the thing that you need to do in this, we have to do this. Yeah, in this situation, remember we are finding the adjacent. You have the what? The opposite. The adjacent and the opposite is this one. So it means supposed to use the what? Tan. Tan theta is equal to opposite over adjacent. So what's the opposite? The opposite angle is 60 there, or the opposite side, it is car respect to the earth. Then adjacent is rain respect to the earth. such that it will be 10 here times 60 is equal to what is the car respect to the earth is 50 over rain respect to the earth, such that your answer will be RE is equal to, when you divide there now, this one times this one, this one times this one, this one times this one, and make RE to be the subject of the formula. Your answer is supposed to be 50 divided by tan 60, or tan what? Tan 60, yes. 50 divided by tan 50 divided by tan what? Tan 60. Your answer to give you 28.9 what? Kilometer per hour. So here the answer is 28.9 kilometer per hour. Here, which is RC, your answer it was 57.7 kilometer per hour, like that. So let's find the last question. So the last question is saying the car is moving with a velocity of 70 meters when a passenger in a car B moving in the same direction at 105 throw a bottle C in front of at the velocity of that. So the first question says state the frame of reference, right? So if you want, you can just do that, the coordinates form. This is the car, right? Car A. Then it was going this side, car A, with what velocity? 70 meters per second. Then it was going to the same direction. Then car B, which was moving at 105 meters per second. Then someone threw the bottle. This is A short. Then car B. Then car B, someone threw the bottle, which went again at what speed? That is C now, right? Which is at what speed? At 20 meters per second. So this is the what? The reference in short. This is the frame of reference, just like that. So how about question 2? Calculate the VAB. So meaning, how are you going to calculate the VAB in this question? You say question 2 there, right? Calculate the what? VAB. So calculate the VAB, meaning it's supposed to be A respect to the Earth plus or minus. All the times supposed to be minus V then B. So what's A respect to the Earth? It's 70, like that, minus what's B? This is B, sorry, this is B. What's B? It's 105. What is your answer? You find that your answer is 70 minus 105. You find that your answer is negative 35 meters per what? Per second. Just like that, right? This is your AB. Now let's calculate the VCA. So how are we going to calculate the VCA? The VCA is VC minus what? VA. Now do we have VC? We don't have, so meaning we have to calculate the VC. So this A it's respect to the earth, then B is also respect to the what? To the earth, which is at this point. But C it's a respect of who? C the respect of what? C B, right? So this is CB, then F. So how are you going to calculate the C? You're also going to say VC. You have to say VCB is equal to VC minus VB. Now we have what? We have that because this C here is respect to the B and what? The F. So it's supposed to be VCB is equal to VC minus V what? VB, like that. So what's VC? VC is 20 there because it's respect to the other cap, which is 20 there, minus here what is that? That's supposed to be 105. So meaning that VC is equal to 20. When this one goes to the other side, that is 105. Then your answer will be, when you put there, to give you 125. It is 20 plus 105, so 125. So your VC is 125. So here I'm going to try to say 125 minus what's your VA? Your VA we already know that is what? 70. So your answer will be 125 minus 70. Your answer will be this one, which is meters per second. So this is how we answer this type of the question. So if you have any question, you are free to ask me, text me. I'll put my number there, so you are free to ask me any question that you feel like, and my email address. Yeah, if you want more questions and more questions and more questions on those stuffs.